Hi, this is Takuma Nakata. I'm an interaction designer based in Kyoto, and with today's tutorial I have a really exciting one. I'm gonna explain how to do an audio reactive thing inside vvvv, and this will be the result we're reaching for today. And yeah, I got really nice feedback on Instagram asking me how to do audio reactive stuff inside vvvv, and of course I never thought of creating this kind of tutorial, but I mean, this is like the thing that I've been doing from the beginning, very beginning, and always when you start with, like, I don't know, Touch Design or any other like Unity or whatever, I mean, audio reactive thing is something that really brings you in, and it's really fun to play with. So I decided to make this tutorial, and it's quite simple, but so at the beginning I'll explain how to do audio reactive stuff inside vvvv, and later on I'll also explain how I made this visual. So if you're just interested in audio reactive stuff, just follow my the beginning. And if you're interested in generating this kind of visual, please go to vvvv instance noodle. I'll put the link below, and please install this one because you need it. Else, yeah, let's get started. So I would just delete this one and open up a new patch. Okay, here we go. So doing audio reactive stuff inside vvv is it's really easy, and it's very like smooth, and I believe it's one of the easiest platform to play with audio reactive stuff. So let me show how to do that. So I said I'll explain how to do audio reactive stuff, but basically in vvv you only have to know this node called FFT, which is meaning of fast Fourier, what was it? No. Fast Fourier transform. I don't know how to pronounce this, but I mean, if you're interested in what the logic behind, just Google it. I'm not really familiar what it's doing, but as far as I know from vvv, is basically it's converting the audio wave to values. Woo. So and yeah, there's two type of FFT. One is D show 9 and D show 4 channels, and the difference is this FFT without 4 channel thing has two output, left and right, and the other one has FFT with 256 spreads, and it has bass out, low mid out, high mid out. And the reason why I like this one, I use this one more, is just because it has specified like area already, so I don't have to think about anything. I just have to connect this to wherever I want. And the reason why I'm not seeing anything is because my microphone is not connected to the right one. So just make sure that you right click and choose the right one, and now you should see some values coming out. Yeah, so let's get in deeper and see what FFT is doing. So this is the sample patch of FFT D show without the 4 channel one, and as you see, what it's basically doing is it's outputting 512 values from the microphone in. And right now my microphone doesn't have left and right, so both of them are showing the same result. But what it's doing is combining them together to multiply it, and it's morphing the input for some reason. I don't know why. There is a reason, and then it's splitting it again. I mean, it's basically should be quite, yeah, it's basically almost the same, but I mean, with this it might look better, but I'm not sure what it's doing. So this thing is showing, so the left part is low sound, So and the right part is the higher sound, and I can't make sound with this frequency, so it's not. Oh, oh, okay. So now it has 512 values, so that I can connect it to a box or whatever and scale it using these values. So that's what FFT is doing. But for today, I'll just use this FFT for channels. And what it's basically doing, if you right click, like the ones with these 3 boxes, you can right click them and open up what it's doing because it has a subpatch inside. And it's actually using the FFT node that we just saw, but it's slicing them and only it's specifying the certain area for bass out, low mid out, high mid out, and high out. And it's also collecting all the 4 different areas and how to say, outputting as a spread with these 4 values. So that's what this guy's doing, and these are the individual ones, and this one has 256 output from the left. So that's what it's doing. I don't have to open this up. So let's see how to play with it. So I have box. I'll make a very simple sample example to show how it works. Transform, translate, and I want to scale it up. So I'll use the scale. Make this one here. And then I'll make a linear spread. And I think I chose the vector one. Now I'm using this one. And then I'll split these to 4. Okay, and I think it's too close, so I'll just move it further. So now I have 4 different boxes, individual ones. And what I'll do is, so this one already contains 4 different 4 values as a spread, so I'll just connect this one to the Y scale. Okay, so this was quite easy. So I already have boxes reacting to the sound. So if you play any music, you can kind of like visualize, make an audio visualizer already. Okay, so that was it for today. No, I still have some more to explain because I mean this is a very basic, and if you want to make a more complicated one, and as I also want to reach out the visual that I showed at the beginning, because I titled my tutorial as a graphics tutorial. So let's see how to make that one. So what I was doing in the previous visual is this. I was using circular spread instead of linear spread, and I think the value is still contained, so I just delete these ones. Count, and so I want to have 256 boxes, and they're at the moment too big, so I'll make them smaller, but the spread is too small, so I'll make this one bigger. Okay, so now I see a circular spreaded boxes reacting to the sound, that at the moment my Y scale is connected to this one, rather than that I need 256 values, so I'll just connect this one. Okay, here we go. So by this I already got a really nice looking circular spreaded boxes reacting to the audio. This is already quite close to what I wanted to show you guys today, but I think I'll go a bit deeper because this is too basic. And yeah, so what I'll be doing right now is I'll be using the constant, and then I'll use pillow. This is a small technique that I use always. I like the fact that with this, each box would look like, how do you say, it has this edge, nice looking edge, so I use this one quite often. And then what I did there was, I think I was Berlin noise. So I had this one connected, and then there's this really nice node called pipette. What it does is, so it outputs the color. Let me open up the sample. So this is the sample patch of pipette, and what it's doing is based on the cursor mouse position, it's getting the color of this position or this position. This part should be blue, 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 green. So you can actually specify which, like, what if you want to get the color from like which position. Right at the moment it's the mouse position, but you can also connect like circular spread here. So then you can kind of have like circulated points of colors, and that's what I'm gonna do for today. So I'll here vector 2D join, and here, and then I'll connect this circular spread here so that I get 256 color from the Perlin noise. And I'll render a preview because I want to see what kind of image it's showing. So at the moment it's like this. I'll change the color. So color layerize this. Just select some random color. Yep, this looks good. Okay. And then I'll change the amplifier. Oh no, frequency balance, and also connect integrate, so that have it moving. Okay. So now this pivot thing is like outputting different types of colors. You see that it's changing, and then I'll connect this one constant. But instead of connecting this one, I want to connect the buffer because if I connect this one, it's gonna be quite heavy, I think. So instead of that, it's better to use GPU for this. So I need to change the constant to constant buffered, and the reason for this is and also. Then I'll also need to connect the transform. There's a dynamic buffer. And the reason for me to do this is because this one has color 40 buffers. So now I can connect this one here. But it's not showing anything because as I showed in the previous tutorial, if you're using the buffer, you need to specify the amount of boxes. So with here, I'll have to count. No, it's okay. Okay, so now I got colored boxes, which looks really nice. Okay, so this is basically what I was doing. I also had a different background because I always like to use this pillow thing so that it's not all black. And I'll connect this one, reconnect this one here. Okay, now this looks closer. So this is basically what I did. Just few different techniques that I use when I have this FFT connected. One is I always try to make put a damper in between, and the reason is because at the moment it's it's reacting to dynamic, and sometimes when you're like doing audiovisual stuff, you don't really want everything to go like too strong. So with this damper thing, you can make it a bit more smooth. So now it looks more natural, like soft. And yeah, this is kind of like all I had. What should I do next? Yeah, so this is basically it. If you want these ones to be connected somewhere else, you can just connect it and plug and play and see what happens. I'll also try to make another one, which is a sphere. Transform 3D. At the moment the resolution is too low, so I'll just make it higher. And then I don't want the, I like this font point thing, but I think the default light position is somewhere else. So I'll just put this in the middle. Okay, now it looks better. And then, yeah, I want this C to change every moment. So just lower. No, this is too low. And oh yeah, so I'll connect one of these high out, let's say high mid out. Then I need to change the color. No, I think the light is too strong. Hey. Okay. I just changed no, I just light, not like this. Okay, this is better. So I just changed the light attenuation on the font directional, and then I connect the high mid out again. So, and also the scale. Yeah, let's change the scale. For this one, I'll use select, and then because the scale needs 3 different values, but I don't want XYZ to be different because then I'll have this weird scaled sphere. But what I'm trying to do is I want to connect this FFT 256 now with 256 spreads, but I want them to repeat 3 times each because I want 3 like XYZ scale to be the same. So for that I use the scale thing, selecting, and so now yeah, the spheres are spheres, so they're not like tilted or like scaled weirdly. And then and connect. I'm gonna multiply this. Like with this gain, you can change the gain of this FFT, but of course it affects everything. So sometimes you need to connect individual multiplier. Like for example, for this, I'll just make it 2. The patch is getting messy. So right now the scale is affecting 2 dynamics, so I'll connect the damper again. So with this one I get a softer animation. Yeah, this is better. Okay, so now it kind of like got the same result as I had in the opening sequence. So if let's see if what happens if I play a random music. And yeah, I downloaded this music from MusicBed. Okay, so I don't like the result because I'm only seeing 1. There's a reason for this. Okay, this looks really nice. I think this is the result that I wanted to display for today. yeah, I hope you liked it. So by using FFT, you can do a lot of audio reactive stuff. I hope this helped. If there's any question related to audio reactive stuff, please let me know. To be correct, vvvv is not really strong with like generating audios. Some of you might be interested in generating audio using vvvv, but because vvvv is frame based, it's not really in a good relation with audio generative stuff. So my suggestion is to use like Ableton Live or something like that and get an audio input from, or like MIDI input from Ableton or like Max MSP to vvvv or OSC. So then you can do a lot of like audio, like you can generate your own audio and send that MIDI data to vvvv and make things react to that. If you're too lazy with that, use FFT. Even though with microphone input, it makes a really nice react. So I hope this helped. See you next time.